Okay, now we move over to exponential function. Now, what is exponential function? A situation whereby the unknown in an equation is at the index or the power. Now, that expression or equation is said to be an exponential function. For instance, if we have 2x equal to 4, okay, or you also may have 3x equal to 9, for instance. So this is called exponential function. You can equally have this at the base. Probably you may have x raised to power 2 equal to 4. Okay? Equal to 4, as the case may be. So when such arise, you call it what? Exponential function. Okay, now the only way to solve this kind of exponential function is to reduce the base to an equal proportion. You know, having the same number at the base will help to get this kind of function solved. Okay, so stay tuned while we bring a lot of examples to illustrate that for better understanding. Okay, solve for x in the following equations. That's the example 1. Now we have this and we have that. Solution. Okay, on this now, this is 9. All right, on this, remember what we said in exponential function. And when you have such a case like this, what you need to do is to reduce the base to reduce it to a common base. Okay, so with this we say 9 is the same thing as saying 3 raised to power 2. So we have 3 raised to power 2. 2x plus 1. Now, 81 is the same thing as saying 3 raised to power 4. 3 raised to power 4. X minus 2 all over 3 raised to power x. So with this now, we remember our power law. Okay, our power law says that when you have an expression like this, you open up the bracket and use the words. They are said to be in powers. So you multiply out the powers. We have this 3 raised to power 2 times 2x is 4x. 2 times 1 is plus 4x plus 2 equal to 3 raised to power 4 times x is 4x minus 4 times minus 4 minus 2 is what? Minus 8 all over 3x. Now from here we can say 3 raised to power 4x plus 2 equal to remember when you are dealing with division rule, it says that you can take the device and minus it out from the dividend. So from here, since these are common, we can say 3 raised to power 4x minus 8. This going up now will be minus x. Okay, now from here we can have that 3 raised to power 4x plus 2 equal to 3 raised to power 4x minus x minus 8. Okay, now looking at this, you have common base between the two, so you can easily cancel this. You can cancel this. Okay, from here now you bring down the base. You have 4x plus 2 equal to 4x, or rather, since you are collecting like terms here, you can say 4x minus x is what? 3x minus 8. So collect like terms. From here we say 4x, 3x crossing equality sign will be minus 3x and equal to minus 8 plus 2 crossing equality sign we have minus 2. From here we say 4x minus 3x will give you minus, will give you plus x now. So we have what? X equal to minus 8 minus 2 will give you minus 10. So this is the final answer. Okay. So quickly we are going to take the second one. Okay. All right. Coming to the second one, we have 2 times 4 raised to power x minus 3 equal to 16 raised to power x divided by 18 raised to power 1 minus x. Okay, now from here, you can simply say 2 times, this 4 is 2 raised to power 2, so we have 2 raised to power 2, still raised to power another x minus 3 equal to, now 16 is the same thing as saying 2 raised to power 4, okay? So we can say 2 raised to power 4, or in brackets, raised to power another x, divided by 8 is saying 2 raised to power 3. So we say 2 raised to power 3, still raised to power another 1 minus x. All right, so from here now, we can say 2 raised to power 1 times 2 here. Remember, these are in powers. So this 2 times x is 2x. Minus 2 times 3 is what? 6. Minus 6. We have equal to. Now this is 2. 4 times x is 4x. Divided by 2 raised to power 2. 3 times 1 is what? 3. And 3 times minus x is what? Minus 3x. So with this, we now we remember our what? The first law, the product law. When you have the same base here, you can simply say that this is 2 raised to power. Whatever you have here, you can what? You can add it together. So what that means is that 2x minus 6 plus 1 is what? Is minus 5. And this is equal to, coming to this side, they have common base, so you have 2. Now, combining these two, you have, remember, when it comes to the second law, we are dealing with what? Division here. So what we do is, we subtract. Okay, we subtract. So in that case, we can say this minus this, 4x. Now minus whatever you have there, because that the divisor, 3 minus 3x. Okay, so from here we move to the other side. We can have that 2 raised to power 2x minus 5 equal to 2 raised to power. Now we have 4 already. We have 4x rather. Now 4x, this minus times this minus 1 times this, we have minus 3 here. And for this one, we say minus 1 times minus 3x, we have plus 3x. Okay, I believe you understand that. From here, we see that the base are common with what? We cancel out. Bringing down the index, we have 2x minus 5 equal to 4x plus 3x. we have 7x minus 3. So from here now we can say collect like terms. So with this we say 2x, this crossing equality sign will be minus 7x minus 7x equal to minus 3 minus 5 crossing equality sign will be plus 5. So with this we have this 2x minus 7x, we have minus 5x equal to minus 3 plus 5, we have what? We have 2. So with this we have 2, divide 2 both sides by what? Minus 5, we have x equal to 2 over 5 in minus sign. Okay, so we have minus 2 over 5. So this is the final answer. Okay, so quickly we are going to bring the second example so I can wrap it up. All right, stay tuned. All right, let's look at these examples. Solve for x in the following equation. 10 raised to the power minus x equal to 0.0001. Number 2 says 1 over 9x, 9 raised to the power x equal to 3 raised to the power minus x. So 3 times 81 raised to the power x. Solution. Now we have 10, that is number 1, 10 raised to the power minus x equal to 0.0001. Okay, remember this. We said that when you have this, you first of all convert it to what? A fraction. Okay, so we have 10 raised to the power minus x equal to 0, or rather equal to 1 all over 10000. If you remember your elementary maths, okay, whenever you want to represent this, you first of all call the what? The point 1, okay, before you now count the number of the number of decimal places. I mean, after the decimal places, the number of things represented there, you complete it with what? 0. After, you must represent the what? The number itself on top. All right. Now from here, we can go further and say that this is the same thing as saying 10 over minus x equal to coming to this 1 over 10 raised to power 4. Okay, are we together? Now from this we can say this is equal to 10 raised to power minus x equal to this thing is the same thing as saying 10 raised to power minus what? Minus 4. Okay, remember our law. Okay, so we can say that this is 10 raised to power minus 4. With this we have common base, and we can now cancel it and have minus x equal to minus 4, and we minus 1 dividing the both sides, we have x equal to 4, and that's the final answer. So quickly we are going to look at the second example. Okay, all right, for the second example, we have 1 over 9 raised to power x equal to 3 raised to power minus x all over 3 raised to power, okay, 3 times 81 raised to power x. So from here now we can say 1 over how many 3 are in 9? We have 2, so we have 3 raised to power 2 all raised to power x equal to 3 raised to power minus x all over 3 times, how many 3 are in 81? We have 4. So we can say 3 raised to power 4, all raised to power x. So from here now we say, okay, still have space here. So we say 1 over 3 raised to power 2, or rather you say, remember this, they are in power, so you can multiply them out. You now have 2 times x is 2x equal to, this is 3 raised to power minus x all over 3 times 3 raised to power 4 times x is 4x. Okay, from here now we move to this side. We say 1 over 3 raised to power 2x, 1 over 3 raised to power 2x equal to 3 raised to power minus x equal to, rather over, now looking at this, remember this is just like saying that there is 1 on top of this. So for the product rule, you have the common base here. We have 3. Okay, we have 3, and the powers will be what? Will be added. So with this we have 4x plus 1. Okay, now further from this we can say 1 over 3, or rather we can now say that this is the same thing as saying 3 raised to power minus 2x. Okay, now with this we say equal to, coming to this side we have, these are common base, so we have 3, and we now have minus x minus whatever we have here. So we have 4x plus 1. So continuing, we have 3 raised to power minus 2x equal to 3 raised to power minus x minus 1 here times 4x here. We have minus 4x minus 1 times minus 1. We have minus 1. So with this we cancel the common base. From here we have minus 2x equal to, collecting like terms here, from here we have minus x minus 4, we have minus 5x minus 1. So this we, collecting like terms now, bring this over, we have 5 minus 5x here. When it crosses the equality sign, becomes plus 5. So we have 5x minus 2x equal to minus 1. Okay, so this will now give you 5x minus 2x is what? 3x equal to minus 1. So this will now be equal to, dividing both sides by what? By 3. We have that x now is equal to minus 1 over 3. So this is the final answer. Okay, so answer is x equal to minus 1 over 3. All right, thank you very much. So we're going to bring you another topic after this, so stay tuned. It will be announced later. All right.